Hi, in this YouTube video I will explain how to calculate Pearson's R, the correlation coefficient. For this exercise I will use 5.68, that is on page 292 in the book. Let's first write down the numbers of the two variables. Variable x, we have 150, 300, 350, 375, 390, and 480. We will first calculate now the mean and the standard deviation. How to do that I have explained in the video on calculating the standard deviation. Therefore I will just write it down now. The mean for this variable is 340,8. The standard deviation is 110,6. The first step in calculating the regression coefficient would be to calculate the z-scores for x. Z of x would be the score minus the mean of x divided by the standard deviation. If we do that for x, we get 150 minus 340,8 divided by 110,6, which would be minus 1.7. This we can also do for the other numbers. 300 would be a z-score of minus 0.4. 350 would be 0.1. 375, 0.3. 390, 0.4. And 480 would be 1,25. This we also do for the y variable. Y, the values are 2.3, 3, 4.4, 5.0, 5.2, and 5.7. The mean is in that case 4.3 with a standard deviation of 1.3. Again, how to calculate that is in the other video. We now calculate the z-scores of y, similar to what we did in variable x. Thus, 2.3 minus 4.3 divided by 1.3, score minus mean minus divided by standard deviation. In this case, that would be minus 1.5. The other numbers, minus 0.9, 0.9, 0.5, 0.7, and the last one, 1.1. Next step, calculate the product of Cx and Zy. So that would be, for the first entry in the data, minus 1.7 times minus 1.5. This gives us 2.5. The other numbers, 0.36, 0.01, 0.15, 0.28, 1.38. Next step would be to sum them all up. Sum z x, z y. First we multiply, then we sum. Would be 4.7. R is the sum of zx, zy divided by the number of observations minus 1. We have 1, 2, 3, 4, 5, 6 observations. Therefore we have to divide by 5. And that gives us a R of 0.95. This is the regression coefficient. The coefficient of determination is R squared. R squared is 0.95 times 0.95. .90. Therefore, the proportion explained variance is 0.90. That's how you calculate the coefficient of determination R squared and the regression coefficient R.